Hello everyone, my name is Tausif, a student of Techno India University pursuing BTech CSE AI. Today I am going to discuss on the topic bubble sort. So in the first slide we can already see our topic bubble sort. Let's move on to the next. Here we can see it is about me, my name, my institution, my course, my semester and on. So here in the context page we can see all the topics which I am going to cover today. So let us start with the introduction. What is sorting? Sorting is nothing but it is a process of arranging items in a specific order, typically ascending to descending or descending to ascending. So why sorting is important in programming? Because it improves its efficiency, readability and performance of many operations. So moving on to the next, let us start. What is bubble sort? Bubble sort is a simple sorting algorithm used in programming. It is used to arrange or sort in specific order. It repeatedly compares adjacent elements in a list and swap them if they are in the wrong order. This process continues until the list is sorted. So why it is called bubble sort? It is called bubble sort because all the larger elements bubble up to the end of the list in each pass, like air bubbles rises to the surface. So here in the algorithm we can see it starts from the first element of the list. It compares the current element with the next element, and in between them it will check which one is greater. If the second element is greater and the first element is smaller, it will not swap. But if the second element is smaller and the first element is greater, it will swap. So here let us understand it by simple step-by-step example. So here I have taken original list 5, 2, 9 and 1. So in the pass 1, it will compare the element 5 and 2. So in between 5 and 2, 5 is greater and 2 is smaller. So it will swap them. Then again it will move to the next element. Now next element will be 5 and 9. Between 5 and 9, they are in the correct order because 5 is smaller and 9 is greater. So it will not swap. It will again move to the next element 9 and it will compare it with its adjacent element 1. So here in 9 and 1, 1 is smaller and 9 is greater. So it will swap. So in the first pass we will get 9 as the largest number and it's in correct position. So here in the pass 2, it repeats the same. It will compare again 2 and 5. It will not swap now because they are in correct order. Again it will move to the next 5 and 1. Now it will swap it because they are not in the correct order because 1 is smaller and 5 is greater. So in the second pass, the second largest element is 5, which is in its place. So now in pass 3, it will again compare 2 and 1 and it will swap because 2 and 1 is smaller and 2 is greater. So now at last we will get 1, 2, 5 and 9. Now no element left, so it no need to check further. Now we have the sorted list 1, 2, 5, 9. Moving on to the next slide, here you can see the C programming which I have done. Here I have taken some example number like 64, 25, 12, 22, 11. Here is the output. We can see the original array is 64, 25, 12, 22 and 11. So it will sort and it will show us the sorted array in the ascending order 11, 12, 22, 25 and 64. So let's come to the complexity of it. Here are some cases and explanation of it and the time taken by. So in the best case it will take very less time because we can say when it will be the best case because it will be the best case when the list is already sorted, only one pass needed with no swap. Means almost swapped list in which it will take very less time and it will be very quick. For average cases, the elements are in random order or need to be multiple swapping, like we have seen there. But in the worst case, where the elements are arranged in reverse order, because to arrange them, it will go on swapping and swapping and swapping and take very much time. For pros and cons, let us talk about advantages and disadvantages. First, about advantages, it is very easy to understand and perfect for the beginners. Beginners can learn very well from this. It is simple to implement with minimal code. No extra code is required. In place sorting, it do in place sorting and no extra memory is required for it. It also preserves the order of equal elements and stable sorting algorithm. But here are some disadvantages of it. It's very slow. So we cannot use it for datasets which are very large or large. And it also performs unnecessary operations when the list is almost sorted. Moving on to the application, it is used for educational use. Commonly used to teach basic sorting concept for the beginners. It is also used to sort small data sets, useful for sorting small or nearly sorted lists. Also checking sorted orders. It can help detect if a list is already sorted or not. And it is also used for stability testing when stability of sorting is important. For example, sorting one by one, keep preserving another. So that's all. Thank you everyone.